All right. So for today, we talked a little bit about it on Monday. Okay. The idea of I can distribute and solve a problem. Okay. It used to be just I can solve. So now it's distributing. So every time I do that, I did that first period too. Erase the end of idea. Okay. So the idea behind this is we're kind of just combining like a handful of lessons we've already had. We're going to be distributing, but we're also going to be still using our two-step process. Okay, so we're going to be seeing some problems that look like this. Okay, so we're going to be seeing some problems that look like that. Now, in and of itself, you wouldn't think, okay, if it was just x plus 3.5, okay, it'd be a one-step process. So you can see we have it in a different form here, but we notice already with our parentheses that we're going to have to be distributing it. So it's important to remember our steps for distributing. Okay? And with our unit where we were talking about expressions, it was easy to forget that second piece and then, and submit it. Luckily with unit 5, because we're going to be actually solving it, once we get a solution for x and we plug it back in and check it, we'll catch the times that we forget to distribute, which is kind of nice. Okay, so if I'm distributing 10 here to both pieces here, 10 times x, okay, that's 10x. 10 times 3.5, that's 35, and 75. Okay, so these two equations, are equivalent. Okay, once I solve for each of these, we talked about how this top one and the bottom one here, before we had equal signs over there, we talked about how one is not more simple or less simplified than the other, right? We talked about that pretty adamantly in Unit 4, and this is kind of the reason for that. Okay, being able to go from here to here and understand that this is not more complex or simple than this, but this is in the form of what we need to do here. Okay, and so I mean, once we're in this spot, we can take 35 away on both sides and get 10x equals 75 minus 35 is 40. Okay, we can divide by 10 on both sides to get these to cancel and get x equals 4. Okay, so we get x equals 4 here. And now the nice thing is you can plug it back into either of these expressions because as we talked about, these are equivalent expressions. And so when I plug a number into either of them, I should still get my same number. Okay, I should still get the same solution. They should both be 75 equals 75. And so I plugged 4 in here. 10 times 4 is 40. 40 plus 35, okay, good, is 75. I plugged 4 in here. Okay, remember your PEMDAS, right? We have to do the inside of our parentheses stuff first. 4 plus 3.5 is 7.5. 10 times 7.5 is 75. So those are both fine. Okay, so when you put these back in and check them, check. When you put these back in and check them, either of them works. And the nice thing is when you plug it back in here, if you feel like, okay, I did, so if you end up in a spot like this, okay, where you distribute and you forget to distribute to the second piece. Okay, and then you go ahead and you go through this and you subtract 3.5 on both sides. Okay, you get 10x equals 10, equals 71.5. You divide by 10 on both sides and you get x equals 7.15. Okay. So Abrina, can it wait like 5 minutes till we're done going over the brand new topic? Okay, that's fine. That's fine. I just don't want you to be gone while I'm going over it. I mean, if you want to stand there for 5 or 10 minutes, that's fine. Okay. So again, we've done our two-step process correctly. Okay, I've subtracted the same amount on both sides. I've divided by what I had coupled with x, and I get 7.15. Okay. However, you can see I forgot to distribute my 10 to my 3.5, which is a super common mistake you guys make. So when I plug it back, I plug this back into here, yeah, it's going to be correct. Okay, 7.15 times 10 is 71.5 plus 3.5, 75. It checks out. But if I plug it back in up here, it's not. It's not going to make a lot of sense. 7.15 plus this is 10.65 times 10. That's 106.65. Okay, something happened. So when you check these, you got to make sure that it goes into the original problem, not just this one. Okay, because the mistake is happening right here. So if I only check to this equation, it's going to look like it's correct. So that's important, is to make sure that when you find a solution, it goes back into the original equation. Because if you put it here, all you're doing is checking your two-step process, not your distributive piece, which is a thing that a lot of people, about 35% of you guys did on the test. Okay, remember when we did the test review, a lot of people forgot that second piece of it. Okay, there is. So again, nothing crazy new here, right? We're just making sure that everything outside gets a dose of what's happening, or everything inside gets a dose of what's happening outside. Okay, even if it's something that's not just a number, okay, like -2 times x plus 4 equals, let's say 4. Okay, something like this. We have to remember that when we're distributing, that we're still distributing everything outside. And the process is not any different. I still encourage you to distribute individually, right? Distribute the 2 first. -2x plus 8 equals 4. You can see x got a dose of 2, 4 got a dose of 2. Okay, and then when we write it again, we flip our switch. -2x plus -8 equals 4. Okay, distribute them individually. Okay, and then go about your process. Okay, we'll also notice we see like add -8. You're going to see positions, you'll be in positions like that. Okay, and remember when we talk about our steps, we're undoing using opposites. So we, if we were adding -8, how would we get rid of it? By minusing a -8, right? But that's like a position we don't like to be in. So if you end up in a spot where you're subtracting a negative, don't forget you still have that 2-mark method in your bag, right? So what's the difference? What's the opposite of adding a negative? We'll just add a positive, right? If I put a negative balance on your account and then I add a positive balance on, it's still the opposite, right? Okay, so remembering what the opposites actually are is important here. Okay, so the last thing is when we have problems like this. X minus 2 equals 44. Okay, so if we had a problem like this, okay, normally the thought would be, okay, let's distribute this. Okay, so if we did that, we distribute it, 4x minus 8, right? 4 times x is 4x, 4 times 2 is 8, equals 44, okay? And we could solve this our normal way, okay? Just like we normally would solve this, right? We just add 8 on both sides. We get 4x equals 52. We divide by 4. We get x equals 13, okay? And I plug it back in, 13 minus 2. Yep, that's 11. 11 times 4 is 44. Okay, yeah, that's fine. Okay, however, there is a little trick to this sometimes. If the number that's out here that needs to be distributed is a factor of our total, we can actually do our steps in reverse. Save ourselves from having to distribute, okay? Because remember, all this is a quantity, right? It's some amount. Like if this was just x instead of x minus 2, we would just divide by 4 to get rid of it, wouldn't we? So that's true with our quantity as well. So in order to get rid of this, I can just take both sides and divide them both by 4. It gets rid of this, and it makes this. So we end up with x minus 2 equals 11. Okay. So there's a little shortcut. It's only when it works. It only works when the number out here is a factor of our total. Okay. So you'll see that a couple times. So that's kind of the new idea that I wanted you guys to see. Then we end up with just a one-step equation, right? Plus 2, x equals 13. So we end up in the same place. Okay, so occasionally that will help you. Notice we did step 2 first. We divided. And then we did step 1 second. Okay, so in that rare instance, when it matches up exactly with being a factor, we can kind of do it backwards. Now, if you're comfortable factoring and you rarely forget to put that second piece of the factor on, just do it that way. Okay, because you won't do this enough to be like all the time. You may see it once or twice. Okay, but I would say getting comfortable distributing is okay. Thank you. Okay, so again, that's the kind of new idea. That's the real only new thing we've seen today. Most of the other stuff is just a combination of our previous units. Okay, this is kind of a cruel lesson because it's like, oh, what are you guys the worst at? Finishing out distributing and working with negatives. Bang, here's a lesson that has both. All right. Oh, you struggle with the two-step process also? Let's throw that in there. Okay. But, again, we end up in spots like this. These are the more complicated ones you're probably going to see. And so we, let's see here. So if we have, let's move this up so we can work with it a little bit here. Just remembering that our main concern is the word opposites, right? Like, yes, when we have +6, the easy way is the opposite is just -6, right? But plus a -6 also is fine, right? Any opposite. Just like how if we have ×6, divided by 6 works. But multiplying by 1/6 is also the opposite, right? So, there are other options with the opposites to get rid of these pieces in our steps. We just have been going with these properties of equality because they're the most simple, right? Okay, the path of least resistance. Does anybody know the phrase, what Occam's razor is? You know what that is by chance? So it's a phrase that says that the simplest solution is usually the correct one, okay? Like the old phrase, if you hear hoofbeats, you shouldn't think zebras, think horses, right? Yeah, that's kind of the idea here. If you have to get rid of something with +6, use -6. There's no reason to overthink it. But in this kind of spot, you may end up not being able to do that. Okay, again, like our opposite of this is going to be minus -8 on both sides. So instead of doing that, just do plus +8 plus 8. Okay, then you end up with -2 equals 8. Dividing by -2. Okay, don't forget our rules when we divide by negatives, right? We have to, and multiply by negatives, we have to count our negative signs, right? 8 divided by 2 is 4. One negative sign tells us this is -8. And again, this is where I was talking about how things were going to get complicated. Okay, in this instance, we have to go back and check and see if our solution was correct or not. Okay. Ooh, I made a mistake, didn't I? This should be not -8. This should be 12, shouldn't it? 4 plus 8 should be 12. So this should actually be -6. Oops. Okay. So I would have plugged in -4 there and got not the correct response, right? I would have plugged -4 in right here. I would have got -4 plus 4 is 0. -2 times 0, not 4. So I had to go back and figure out where I messed it up. So again, taking these and plugging them in. -6 up here, -6 plus 4, they're opposites. You have to subtract. 6 minus 4 is 2. 6 has more absolute value, so -2. -2 times -2, 2 times 2 is 4. 2 negative signs, the answer is positive. -6 checks out. Okay. So this is kind of the cumulative lesson of all the different things we've talked about, right? Adding and subtracting negatives, multiplying and dividing by negatives, distributing, two-step process. It's all kind of in there, okay? Again, luckily, we have this trick of Well, once I get a solution, I can just plug it in and see if I got it right or not. So there's that fallback at least. Okay. So once more, not anything revolutionarily new. Okay. Relative, just an accumulation of everything. Okay. Took that off there, so angry. Okay. All right. So I'm gonna put a red circle right here so that you guys don't forget that that's bad. Okay. Now I'm gonna put a line right here also, so it says or. Okay. And I'll leave this up here as you work through them. Most of your Excel stuff today, I think it's only 8 or 9 problems. It was shorter than I thought it was going to be. A lot of it is just they want to see you distribute the pieces, then they want to see you do the 1 and 2 step process. Okay. So again, thinking about this mistake that is the most common, making sure that when you do distribute, that everything gets distributed. It's easy to lose this negative too. You know, and if you did that, if you lose the negative or it just stays out here in negative front, right, you end up subtracting it, you get -4, you divide, you get +4, and when you check it, it's 8 times 2, that's 16. Okay, something happens. Again, that's the beautiful thing about this lesson. I think it's one of my favorite lessons. Okay, it's like one of the only things we do where you can literally look at the answer that you got every single time and check and see, is this the correct answer or not? It's like, you know, it's like being able to do your work and then check the key, basically. You know, I mean, I think it's nice. It just takes a little bit more motivation, a little more effort to do that. You know, it's for me at least. I like those lessons because I like to know for sure if I got it correct or not. You know what I mean? Yeah. Okay. So questions about anything on this unit? Nothing, like I said, nothing crazy new, but just kind of a combination of everything. Okay. All right. Cool. All right.